Chapter number 2, Applications of Derivatives. Dear students, we are going to study new concept, increasing and decreasing functions. First, increasing function. Definition. A function f is said to be monotonically or strictly increasing function on an interval ab, open interval ab, if for any x1 x2 belongs to open interval ab with if x1 less than x2, we have f of x1 less than f of x2. Here value of x is increasing, then the value of function is also increasing. This function is increasing function. Consider an increasing function y equal to f of x in open interval ab. Let h greater than 0 be a small increment in x. Then in this figure we take the function y equal to f of x. On the x-axis take 2 points x1 and x2. Distance between x1 and x2 is h. H is very small. At a point x1 value of a function is f of x1. Also at a point x2 value of function is f of x2. Here value of x is increases x1 to x2. Also the value of function is increases f of x1 increases then f of x2. Therefore this function is called as increasing function. In this figure f of x less than f of x plus h, that is f of x1 less than f of x2. Therefore f of x plus h greater than f of x. Take f of x on LHS, then f of x plus h minus f of x greater than 0. H is a small increment. Suppose we divide by h. F of x plus h minus f of x divided by h greater than 0. We take the limiting position, that the limit h tends to 0. F of x plus h minus f of x divided by h. Here is small changes, therefore greater than equal to 0. We know that definition of derivative f dash of x equal to limit h tends to 0 f of x plus h minus f of x divided by h. It is a derivative of function that is denoted by f dash of x greater than equal to 0. This is the condition of increasing function. If f dash of a greater than 0, then in a small delta neighborhood of a, that is a minus delta, a plus delta, we have f strictly increasing if f of a plus h minus f of a divided by h greater than 0 for mod h less than delta. Hence if 0 less than h less than delta, then f of a plus h minus f of a greater than 0 and f of a minus h minus f of a less than 0. Here is thus for 0 less than h less than delta, then f of a minus h less than f of a less than f of h. Decreasing function. Definition. A function f is said to be monotonically or strictly decreasing function on an interval ab if for x1 belongs to x2, x1 and x2 belongs to ab with x1 less than x2, we have f of x1 greater than f of x2. Here is x1 less than x2, but the function is opposite, f of x1 greater than f of x2. Consider a decreasing function y equal to f of x in interval ab. Let h greater than 0 be a small increment in x. X equal to x1, x plus h equal to x2 in this figure. In xy plane, take first quadrant. Here is a curve. That is the function y equal to f of x. x1 and x2. x1 increases to x2. But here is function. At the point x1, here is value of f of x1. Here is the curve is decreasing. Curve is decreasing. Value of f of x1 is less. And we get the f of x2. Here is x1 variable increases and the y, that is the function f of x, is decreasing. This function is called as decreasing function. Here condition is x1 is x, x plus h is x2. That is x plus h greater than x, but f of x plus h less than f of x. Suppose f of x take on LHS, then f of x plus h minus f of x less than 0. H is a small increment, we divide by h. F of x plus h minus f of x divided by h less than 0. We use the limit. Limit h tends to 0. Suppose this condition. Here is h. This distance tends to 0. Apply. Then there is small changes. Limit h tends to 0. F of x plus h minus f of x divided by h. Value is less than equal to 0. We know that it is the derivative that is denoted by f dash of x less than 0, which is the condition of decreasing function. If f dash of a less than 0 in a small delta neighborhood of a, that is a minus delta a plus delta, we have f strictly decreasing because f of a plus h minus f of a divided by h less than 0 for mod of h less than delta. Hence for 0 less than h less than delta, f of a minus h greater than f of a greater than f of a plus h. Note, whenever f dash of x equal to 0, at that point the tangent is parallel to x-axis. As the slope of x-axis is 0, that means derivative is 0. Also the lines parallel to x-axis, its derivative is 0, its slope is 0. We cannot deduce that whether the function is increasing or decreasing at that point. Examples. Example number first. Show that the function f of x equal to x cube plus 10x plus 7 for x belongs to R is strictly increasing. Here we have to show that function is strictly increasing, means its derivative is greater than 0. Solution. Given that f of x equal to x cube plus 10x plus 7, differentiate with respect to x, f dash of x equal to derivative of x cube is 3x square plus 10 is a constant multiple, take outside, derivative of x is 1 plus 7 is a constant term, its derivative is 0. Therefore f dash of x equal to 3x square plus 10. Here 3 is a constant term, x square is also positive. Therefore 3 multiplied by x square is greater than equal to 0 for all x belongs to R. And we know that 10 is also positive, 10 greater than 0. Therefore their addition 3x square plus 10 greater than 0 implies f dash of x greater than 0. Thus f of x is strictly increasing function. Example second. Test whether the function f of x equal to x cube plus 6x square plus 12x minus 5 is increasing or decreasing for all x belongs to R. Here we have to check its derivative is greater than equal to 0 or less than equal to 0. Solution. Given that f of x equal to x cube plus 6x square plus 12x minus 5. Differentiate with respect to x, we get f dash of x equal to 3x square derivative of x cube plus 6, take outside, derivative of x square is 2x, 2x into 6 is 12x plus 12, take outside, then derivative of x is 1 minus 5 is a constant term, its derivative is 0. Take 3 common, then we get x square plus 4x plus 4. F dash of x equal to 3. Here is square number. Square of x. 4 is a square of 2. Middle term sign is plus. Therefore, it is a x plus 2 square. That is x square plus 4x plus 4. 3 is a constant term. It is positive. Here is square. Square is also positive. Therefore, 3 into x plus 2 square is always positive for x not equal to minus 2. Therefore, f dash of x, its derivative, greater than equal to 0 for all x belongs to R. Hence, f of x is an increasing function for all x belongs to R. Example 3. Find the values of x for which the function f of x equal to x cube plus 12x square plus 36x plus 6 is first monotonically increasing or second monotonically decreasing. Here we have to find the values of x. Take both conditions, increasing or decreasing. Therefore, take its first derivative greater than equal to 0 or less than equal to 0. Solution. Given that f of x equal to x cube plus 12x square plus 36x plus 6. Differentiate with respect to x. F dash of x equal to derivative of x cube is 3x square plus 12. Take outside derivative of x square is 2x. 2x into 12 is 24x plus 36. Take outside derivative of x is 1 is 36 plus 6 is a constant term, its derivative is 0. Hence f dash of x equal to, take 3 common, then we get x square plus 8x plus 12. F dash of x. We factor this quadratic equation. Here x square coefficient is 1, constant term is 12, multiplication is 12. We find two numbers, multiplication is 12 and addition is 8. Here is two numbers, 6 into 2. Multiplication is 12 and addition is 8. Therefore, the factors are x plus 2 and x plus 6. Therefore, f dash of x equal to 3 into x plus 2 into x plus 6. Condition first. F of x is monotonically increasing if f dash of x greater than 0. Here we have to find the values of x. That is, f dash of x is 3 into x plus 2 into x plus 6 greater than 0. 3 take on RHS, we get x plus 2 into x plus 6 greater than 0. Then either. Here is multiplication is positive. Therefore, both terms are positive or both terms are negative. Plus plus, then it is positive. Suppose this minus minus, then minus minus multiplication is plus, is also greater than 0, that is positive. Here is first condition, x plus 2 less than 0 and x plus 6 less than 0. We take both are negative, or x plus 2 greater than 0 and x plus 6 greater than 0. We take both are positive. Case first, x plus 2 less than 0 and x plus 6 less than 0. Implies x is less than minus 2 and x is less than minus 6. Here is minus infinity to minus 2 and minus infinity to minus 6. Both conditions are satisfied by x is less than minus 6. X plus 2 into x plus 6 greater than 0, hence f is monotonically increasing. Case second, if both are positive, x plus 2 greater than 0 and x plus 6 greater than 0. This implies x is greater than minus 2 and x is greater than minus 6. Then minus 2 to plus infinity and minus 6 to plus infinity. Both conditions are satisfied by x is greater than minus 2. Then x plus 2 into x plus 6 greater than 0 and f is monotonically increasing. Therefore, from case first and case second, f of x is monotonically increasing if and only if x is less than minus 6 or x is greater than minus 2. Hence, x belongs to minus infinity to minus 6 or x belongs to minus 2 to plus infinity. This implies f is monotonically increasing. Second, f of x is said to be monotonically decreasing if f dash of x less than 0. That is, derivative is less than 0. Its derivative is 3 into x plus 2 into x plus 3, x plus 6 less than 0. 3 take on RHS, we get x plus 2 into x plus 6 less than 0. Then either. Here is multiplication is negative, then both terms. Suppose we take first positive, then second negative. Also, second condition, first negative, then second is positive, we get x plus 2 less than 0 and x plus 6 greater than 0 is first condition. Here is negative, positive. Second condition, x plus 2 greater than 0 and x plus 6 less than 0. Here is positive and negative. Case first, x plus 2 less than 0 and x plus 6 greater than 0. From first condition we get x is less than minus 2 and second condition x is greater than minus 6. Thus for greater than minus 6 or less than minus 2, we take the interval x belongs to minus 6 minus 2, f is monotonically decreasing. Case second, Here is first term positive or second term negative. Here is plus 2 take on RHS, plus 6 take on RHS, we get x is greater than minus 2 and x is greater than less than minus 6. Greater than minus 2 the numbers are minus 1 0, less than 6 is minus 6 is minus 5 minus 4. Here conditions, both conditions are not satisfied, therefore this case does not arise. Thank you.